All right, ladies and gentlemen, this is Professor Parker with All This Math. This is the daily All This Math IG Live installment where we go over problems on the board. And we're running a little late tonight, but it's cool. We have some things come up. Tonight, we're going to talk about scientific notation, right? Before we do that, I want to give a shout out to ASCAC, the Association for the Study of Classical African Civilizations. Due to the COVID-19 pandemic, the annual conference, which was set to take place out in LA this past weekend, actually, or no, the first weekend in April, it was canceled. But I definitely want to shout out ASCAC. ASCAC has done a lot to help to develop me intellectually and also culturally as well. Founded back in like 1984, 1985, I want to say, by the late Dr. Jake Carruthers, Dr. Asa Hilliard, Dr. John Henrik Clark, Dr. Joseph Ben-Jochannan, and some others. ASCAC is a great organization that has done a lot to provide information and knowledge that we can build upon in order to, as the late Dr. Carruthers would say, get out of this mess that we're in. So it's not about just sitting around reading books and just we can sit back and feel like we're smarter than people. It's about actually taking that knowledge from the books and applying it to real life scenarios and real life situations and doing some independent nation building for our people. All right, so I'm going to shout out ASCAC. And this hoodie is from the 2017 conference that me and my young boy Nassim went down to. Nassim, my 14-year-old son, who attends George Washington Carver High School for Engineering and Science. We went down and we actually co-wrote a paper and presented on actually a paper about blacks in science and ancient Africans in science and the future of Africans in science. And we presented down there. The conference took place at Dillard University, historically black college in New Orleans, Louisiana. So shout out to Nassim, and that was a great experience. So tonight we're talking about something scientific in scientific notation. All right. So this is like one of the type of skills I like to call or refer to as like what I call a quick hitter, because it doesn't take a whole lot of time to explain, but if it's not properly explained to you, then you won't understand it. And this is something that you should understand for your mathematics courses. It's also something that you should understand for your science courses, right? Because it's called scientific notation. So we got two examples up here. We're going to convert the first number from standard form, which is how it's given to us, into scientific notation. And then the second one is given to us in scientific notation, and we're going to convert that one into standard form. All right. So the first thing you want to do is you want to read the problem, right? In this case, you want to read the number. So you want to make sure you read the number correctly. And number one, we have 4,832,647.58. All right. Or you can think about it as money, $4,832,647.58. Either way, we're going to convert this into scientific notation. Now, it's a couple things you want to do or want to think about when you're trying to work with scientific notation. The first thing is you need to create a number that is between 1 and 10. Again, you need to create a number that's between 1 and 10. Now, how do you do that, though? Right? The way you do that is you manipulate the number that you're given by moving its decimal point. Now, in this particular problem, we have a decimal point written right here. That's not always going to be the case. Sometimes there won't be a decimal point written. Like, for example, if I give you the number 65, there's no decimal point written there. But we know, again, what's understood don't need to be said, right? Think about that and apply that to mathematics. There's a decimal point that's invisible that's right here. So you could also think of the number 65 as 65.0. All right? But in this particular number, it's given to us with a decimal point written. So with the decimal point written, we want to move the decimal point, either slide it to the left or slide it to the right in a way that's going to give us a number that's between 1 and 10. Now, I know that if I slide this decimal point to the right, I'm just going to have a bigger number, because that's what happens when the decimal point moves to the right. But because this number is in the millions, and I want to create a number that's between 1 and 10, right? So it's going to be, a single digit number, or it's going to be less than 10 but greater than 1. I know I need to slide this decimal point to the left. So that's the first thing I do. I slide the decimal point to the left. So I go, matter of fact, let me use green. Take advantage of my different colors. All right, so I'm going to slide the decimal point to the left because, again, I want to create a number that's between 1 and 10. So I go 1, 2, 3, 4, 5, 6. Right? Is that right? Yeah, 6 spaces. Because it's 1, 2, 3, 4, 5, 6. It's six digits. So it should be 6 spaces, right? Now, I'm going to write down my new number that I just created. So my new number is now 4.8326478. So that number is in between 4 and 5. It's greater than 4, but it's less than 5. Because the decimal point is between the 4 and the 8. So 4.8, whatever, whatever, whatever. So I'm going to write that number down because in scientific notation, you have 2 parts. You have a number part. I forget the technical term for that first part, that first number though. But you have a number part, and then you have the number 10 raised to a certain power. All right? I don't have the terminology escapes me right now. But just know that you have a number times 10 to a certain exponent or a certain power. So we're going to write this number. So we write 4.8326475.8. That's the first part. Right? That's going to be the first part. All right? Now, well, follow me on Instagram at All This Math. Let me erase this because this is going to be in my way right now. All right? Now, the second part, or the second thing I want to write is a multiplication sign. I want to write an X, right? To represent multiplication. All right? And then I want to write the number 10. Right? Because everything in scientific notation, you're always multiplying by 10 raised to some power. Right? So then we got to figure out, okay, what number should be the exponent of 10? Now, how do you figure that out? You go back to the original number you had, right? And then you ask yourself, how many spaces did I move? How many spaces did I move the decimal point? I moved the decimal point 6 spaces. And then the question, so you might want to write that down on your paper somewhere. So I moved 6 spaces. And then what direction did I move? I moved to the left. Right? So I moved 6 spaces and I moved to the left. Now, because I moved 6 spaces, I know that my exponent is going to be a 6. So however many spaces you move the decimal point, that is what your exponent is going to be. So in this case, it's going to be 6. But another question you have to answer is, should that be a positive 6 or should it be a negative 6? Now, if you move to the left, you might be thinking, well, negative numbers are to the left on the number line. So that should be a negative 6. You have to do the opposite. Because you want to think about what direction would you have to move in order to get back to standard form. So if I move to the left 6 spaces, instead of thinking of that as negative 6, I'm going to think of that as positive 6. So think about it like this. When I move to the left, the exponent is positive. When I move to the right, the exponent is negative. Again, when I move to the left, the exponent is positive. So there should be a 6. I'm going to leave the box right. I'm going to leave the box there. So this should be a 6 right here. So this number, written in scientific notation, would be 4.8326475.8 times 10 to the 6th power. So a couple things you want to remember. You want to remember that locate your decimal point. Move your decimal point whether to the left or the right. It could be to the left or to the right. Whatever way you have to go in order to create a number that's between 1 and 10. Now, I couldn't go 5 spaces because that would have gave me 48.3264758. 48 is not between 1 and 10. 48 is greater than, this number would have been greater than 48, but less than 49. You need a number that is greater than 1 and less than 10. All right? So you got to create a number that's greater than 1 and less than 10 by moving the decimal point. But then you want to keep track of how many spaces did you move. All right? So however many spaces you moved, that should be your exponent that goes on to 10. Right? But if you move to the left direction, it should be a positive exponent. If you move to the right direction, it should be a negative exponent, like we have in number 2. All right? Now, number 2, we already are in scientific notation. We're given the number in scientific notation, and now we have to convert to standard notation. All right? So now this is how we do this. We have 3.74 times 10 to the negative 8 power, right? All right, so this is the information. This tells me, this number right here, this 10 to the negative 8 power, in scientific notation, it tells me where I should move this decimal point to get back to the original number that it was before it was converted to scientific notation. Now, the negative exponent means, now this is what you do when you start out in scientific notation. When you start out in scientific notation, you just follow, the general approach that you would assume. When you have a negative number, you go left. When you have a positive number, you move right. So dig this. I got negative 8. So that means I need to move this decimal point 8 spaces, and that's negative, to the left. 8 spaces, and that's negative, to the left. 8 spaces, and that's negative, to the left. All right? Now, you might be thinking to yourself, all right, cool, we're going to move the decimal point 8 spaces to the left, but if I go 1 space, there's no more numbers before the 3. So what am I supposed to do? Whenever that happens, you use placeholders. The placeholders are the number 0. The number 0 is our placeholder. So that means if I move the decimal point 1 space, and now it's in front of the 3, but I still got to go how many more spaces? If I got to go 8 spaces altogether, and I already moved 1 space, that means I got to move it 7 more spaces. So that means I need 7 space holders, or 7 placeholders. So I need 7 zeros in front of the 3. So keep that in mind. So, but what I'm going to do is, I know I'm going to have a decimal. So just to make the number neater, I'm going to start it off with 0 point, right? Sometimes, I mean, you don't really need to write this 0, but it just makes the number look neater. Because you could just write point, whatever, whatever, whatever. But it makes it neater, I think, if you write 0 point, whatever, whatever, whatever. All right? So I got my 0 point. Now, again, I needed to move the decimal point 8 spaces to the left. I moved it 1 space, and I'm in front of the 3. I would still need to move it 7 more spaces, though. 7 more spaces. So that means I need 7 placeholders, or 7 zeros. So what I'm going to do is I'm going to write my 7 zeros after the decimal point. Now, you might be thinking, is this 0 one of those zeros? Nah, this is on the other side of the decimal point, right? So I need 7 zeros after the decimal point. So I do 1, 2, 3, 4, 5, 6, 7. Then I do my 3, the 7, and the 4. And that's the number in standard form. Now, in case you're wondering, well, what's the point of scientific notation? Why do we use it? We use scientific notation so that way we can actually take up less space when we're writing numbers. That's one reason. So we can take up less space. Because look at how much space we had to take up writing all this out, right? And how many digits we had to use. But if we write it like this, we just write 3.74 times 10 to the negative 8. Also, you'll see this on your calculators, right? A lot of times we do multiplication or division with really big numbers, or you do division with really big numbers and you get like a decimal. You might see a capital letter E and then a number after that. That's the exponent. Like in this case, the 6 from number 1, from the first example, right? So, but think about it. Number 1 started out in standard form. We converted to scientific notation. And number 2, we started out in scientific notation and we converted to standard form. Now, we can prove that this is correct because in order to convert this to scientific notation, which is what we started out with, we would just take the decimal point and move it not to the left, but to the right in order to create a number that's between 1 and 10. So we would do 1, 2, 3, 4, 5, 6, 7, 8, right? 8 spaces to the right, so that means my exponent should be 8. And then what do you do when you move the decimal point 8 spaces to the right, or any number of spaces to the right? The exponent should be negative. Because remember, when you move to the left, it's positive. But when you move to the right, it's going to be the opposite, which is negative. So like I said, this is like what I call like just one of the quick hitter topics from mathematics that I wanted to go over today. It doesn't take a whole lot of time. You definitely should practice these types of problems. But these are the steps for scientific notation. These are some basic examples. It gets deeper than this, and the problems get a little more funky, a little more weird at times. But this is the fundamentals of scientific notation, converting to standard form and converting from standard form back into scientific notation. So I want to thank you for tuning in. Hopefully you learned something. Send your DMs to the All This Math DM, and your problem might end up on the board. Peace.